Hello and welcome back to Historical Geology. I am Robert Lopez. I'm going to continue on with activity 1.3 and hopefully get through all the rest of the samples here. So we're on sample 96, which is a Neuroptis fern, Pennsylvania mint age. And when we look at this sample, again, the first thing you want to notice is that it's impression on a shale. So this is probably some palatial, swampy environment. You can sort of see the fissile nature, the layers of the shale there. And so this was caught between layers of fine sedimentation and quiet waters along some marshland or nearshore swamp or bog. Right, so that'd be the paleo environment, terrestrial or transitional, kind of a swampy area. What type of preservation do you think this is? The actual organism is pretty much mostly gone and the volatile elements have disappeared. I can see some nice little details on the shape of the leaves, but I don't really see too much. Oh, maybe there is some detail on the internal structure. I see some internal structures in here of what these leaves look like in real life. So there is some detail. So remember, when we have impressions, we either have that carbonization or that distillation. So think about what you might want to call this mode of preservation. And again, this is a fossil that probably has no symmetry because it's a plant, maybe bilateral. But anyways, that's sample number 96. Now the next sample is going to be sample number 101, which is actually a trilobite fossil. This sample is quite interesting in that we see the organism. Remember, Thacops has a big nose, but it's very clear it has a compound eye. So you can see the compound eye, just like a fly would have a compound eye. But this fossil of Thacops here, you can see it's kind of rolled up. Now you can see it, the whole face and the second eye kind of over there on the left there. And if we kind of look at the back side of this, you see the fossil kind of comes around. You can see him right in here as well. You can see the tail of the organism right here. So you see the tail of him here. And if I flip it around, so these guys curl like roly-poly bugs, right? Like isopods. So they're related to the isopods, but they're obviously a little bit different. They're actually phylum Trilobata. What type of preservation mode is this? You can see that part of the external exoskeleton of this trilobite is kind of wearing off. And I can see lots of details on the pleural lobes and the medial lobes. So it could be unaltered preserved parts, or it could be a replacement that's keeping the fine details. Because I see the kind of the structure of its big nose there and the compound eye. So it's really preserving that nice detail. Again, in a shale, this is limestone. And I'm not going to put acid on it because I don't want to damage the fossil, but it will fizz in acid. So it's still calcium carbonate. And you'll see that arthropods also make their shells out of calcium carbonate and chitin, a combination. So it will fizz if I add acid to it. And again, decide whether it's benthic, necton, and fill in those boxes as well. So the next sample is sample number 43, which is actually a Lycopod. And Lycopods were really quite abundant in the Carboniferous, and you can sort of make out. And what's unusual about this fossil here, this is an impression of the bark of the tree. The bark of the tree. What we have here is actually a replica, and you can see it's this plastic. So what the company where I got this fossil from, this replica, what they did, they just had the fossil and they put the plastic resin over it, let it dry, and then they had this replica. So if anything, this would be cast, right? Like making a cast. So and it would be the surface cast. So of that tree. And again, a terrestrial organism. This lived in kind of marshy swamplands as well. Similar to the Neuropsis fern there. But these were big trees that lived in that area. The next sample is the Graptolite Monographnus. And graptolites are colonial planktonic organisms. Let's see if I can zoom in. Maybe that helps a little bit there. So you can see these carbon impressions right here. And I can't zoom in very much, but you can see there's each one of these little bumps is actually a little cup. And the little cup is called a theca, is where the little organism lives. So on this one little stem here, there's probably 1, 2, 3, 4, about 6 individuals right there. And so and in this, you can see the little theca cups right in there. So again, these carbon impressions, there's a little bit better view of it. Yeah, so you see the little cups right there along that stem there. So these are floating in the ocean. They're weak swimmers, so that can tell you what their environment is. And they're all over. So they're really good index fossils for this time period because they're all over the ocean. So that's sample number 98, these impressions. So see if we can. Now the next sample is sample 18, a gastropod, which is a snail, Polygyra. And when we look at Polygyra, the first thing to note about the mode of preservation is that this is more of a chalky material. The original shell of the snail is gone. And this seems to be, the shell was filled with sediment, and then the shell was dissolved, and all that's left is this. And it looks like it's an internal mode, and there's a special word we use for that internal mold. Now, note that what type of symmetry? Is it planispiral or conispiral, right? So think about, so the little snail would come out this opening that was up here at the top. The opening would be right in here, right? And so you can see that this kind of corkscrews around. Again, snails are mobile organisms. The next sample is number 39, which is a shark tooth from the Eocene. And number 39, this is about the only hard body part of the shark. Remember, sharks are cartilaginous fishes. This is usually the fossils you find of sharks are these. And so this would be the original material. It's more of a calcium phosphate. And so this material is a hard body part that was preserved, and it's an unaltered remain. And then obviously sharks can swim fast, and they can be in either deep waters or shallow waters. All right, so that's sample number 39. The next sample, number 5 here. This sample number 5 is a Brachiopod. And this Brachiopod, there's two things going on here. On this side, I see the fossil, but this would be an internal mold. This would be an internal mold. And then this would be if the external mold in here. You can see the external mold. And unfortunately, we're only seeing one side of the shell. We don't see the second side, but these organisms have shells of two different sizes. And I can tell because this has that very prominent beak is what we call that. And it's really, this beak is where the Brachiopod would have a pedicle coming out here and would attach to the sea floor. So in life, it would be attached to the sea floor. And this top valve here, or top shell, is called the brachial valve. So there's two things going on here. So the mode of preservation is obviously there's some replacement. And because I can still see some of the fine details of you can see the growth patterns there. So there's still enough detail in the organism to tell me that it's replacement rather than recrystallization. And then I have both the internal mold here and the external mold over here. Now your job is to tell me what type of environment this organism lived in. So that's sample. Then we'll look at sample number 41, which is a coprolite. So coprolites are fossil dung, and this is a nice little, cute little dung, probably from a mammal. In terms of preservation, obviously it's not poop anymore, otherwise it'd be staining my fingers. So, but it's turned into a hard, so there's some sort of petrification, right? It's been petrified. In this case, what type? Is it a recrystallization or is it just a mineral replacement? And again, this is going to be some terrestrial organism, right? So there's no marine habitats that you need to check off, right? So that's number 41, the coprolite. The next sample is number 36, which is an ethanoid, and this one's quite interesting. An ethanoid, this is a particular ethanoid, similar to the sand dollar we saw. This is more of a sea urchin. I can see some of the details in this. It has that pentamural or five-fold radial symmetry, and these. So you got 1, 2, 3, 4, 5, right? So that's what we're kind of breaking it out. But these areas are very porous in here, and then this would be the test of the sea urchin here. You can see that obviously the original material is gone, so there's either replacement or recrystallization. But the question is this an internal mold, or is it, which would be a steinkern, or is it a cast? And it might be. The fact that I still see the pore spaces in here, I think it might be an internal mold right? So one of those Steinkerns. This is a little tricky. It is composed of calcium carbonate as well, but it's a different calcium carbonate in the original material. So that's sample number 36. Sample number 19 is a Brachiopod. So this is one of these articulate brachiopods. So this Brachiopod, similar to the one I just showed you, which is also an articulate brachiopod, you can see that the shells are two different sizes. So this brachial shell, and then there's a pedicle shell down here, which is a different shape and size, right? So that's what gives it a different symmetry. So the symmetry is not between the shells, because the suture between the shells would go right through here, right? So you can see it's not a mirror image there. The mirror image is going to be between or through the valves through here, right? Now, this particular organism does show good details of the different structures on its shell, so I don't think it's the original shell material. It's probably been replaced, so it's probably some sort of replacement. So a Brachiopod here, number 19, and that was our last sample.